What is up, everybody? Welcome to 4.1, 4.2, in radical rational expressions and rational, it should be rational exponents, because we are dealing with rational exponents. So, what's the nth root? Now, the nth root, you've been dealing with square roots and cube roots. You've been dealing with squares and cube roots. And the nth root is the root of any number n. So, it could be the 37th root or the 1/3 root. Yeah, it can be the root of any number. So if you want to find out the nth root of something, then you gotta do as follows. For example, if you want to find out the fourth root of 81, well, 81, when a prime factor 81, 81 is equal to 3 to the fourth, right? 81 is equal to 3 to the fourth. So the fourth root of 3 to the fourth is just gonna be 3. So fourth root of 81 is equal to 3, and that's the nth root, right? But more often than not, the nth root is going to be expressed like this, where n to the power of a fractional exponent is equal to the b root of n to the a power. So we're gonna do it. Evaluate 81 to the third power and the fourth root. So 81 to the third power and the fourth root. So we already know our 81 to the fourth root. 81 to the fourth root is 3. So 3 to the third power. What's 3 to the third power? 3 times 3 times 3? 27. Simple. Next, we have 64 to the 1/6 power. 64 to the 1/6 power is the sixth root of 64. So the sixth root of 64 is something that has to be multiplied 6 times in order to get out of the root. So 64 is 2 to the 6th power, luckily. So the answer is just going to be 2, right? Next, n to the 3/4, n to the 1/2 over n to the 5/6. Now, if you guys have learned your operations with exponents, you guys will know that if you multiply two exponents together with the same base, then you will add them. So n to the 3/4 plus 1/2 is n to the 5/4, or n to the n to the 5/4, and down here is still n to the 5/6, and then n to the 5/4 divided by n to the 5/6. They have the same base, and they have a divide symbol through it to subtract the exponent. 5/4 subtract 5/6 is equal to 30. 24 minus 20. 24. I could have made it simpler. That's 10. 24 or 5, 12. So the answer is n to the 512, and that's the answer. N to the 512, right there. Right. Next, we have 3 to the 7/9 plus 9 to the 1/9. Now they have different bases. So it might seem like it's hard, but it's not that hard, because 9 is 3 squared. So we can fix our 9, so we have 3 to the 7/9. And then 9 is our 3 squared, so 3 squared to the 1/9. And then our power of power rule. So when you put a power on top of power, no matter what base it is, you multiply the power. So 2 times 1/9 is 2/9. Now we have 3 to the 2/9 and 3 to the 7/9. 7/9 plus 2/9 is 9/9, so it's 1. 3 to the 1, which is just 3. It turned out really well. It turned out a lot better than you probably would have thought. Okay, so if it's a negative, if the answer turned out to be a negative, you have to flip and then you do the exact same thing. So reciprocal, and then you do the exact same thing. So evaluate 9 to the 2/3, 3 to the negative 3/4. We'll do the exact same method. I don't think this will turn out as nice, but we'll see. Right? 3 squared to 2/3, 3 to the negative 3/4. 3 squared to the 2/3 is 3 to the 4/3. And then 3 negative 3/4, that's 3 negative 3/4. And we can add 4/3, or we can do 4/3 minus 3/4, which is 16 over 12, subtract 9 over 12, which is 7 over 12. So the answer is 3, 7 over 12, or 12th root of 3 to the 7th power. Yeah. The answer is 3 to the 7 over 12. There we go. 100 to the 1/2, 10 to the negative 1/2. This is the same ordeal. 100 to the 1/2, 10 to the negative 1/2. This is the same ordeal. 10 to the 1/2 is 100 to the 1/2 is 10 squared to the 1/2. So 10 squared to the 1/2. 10 to the negative 1/2, which is just 10. 100 to the 1/2 is just 10 because it's the square root of 100. What's 10 times 10 negative 1/2? It is 10, 1 plus negative 1/2, so that's 10 to the positive 1/2, which is just square root 10. Done. I don't think that fits. 10 positive 1/2, which is square root 10 right there. Okay, n to the negative ab, n to the ba. So we'll use this exact same principle. So negative ab, n to the negative a over b plus ba, b over a. So let's do it. Let's do negative a over b plus b over a equal to. Now this is ab. This first thing's negative a. So our common denominator has to be ab because we don't know what the factors of ab are. We assume that they're both prime, ab and ab. This one is missing. Okay, from the ab, this one's missing an a. So this one has to get an a as well. So like a over a, multiply like that. So now we have negative a squared, and then plus this one's missing a b, because in order to get a b, you gotta multiply that by b as well. So b squared. So the answer is b squared minus a squared over ab. A plus b plus a, b minus a. Yeah. So the answer is n times b squared minus a squared over ab. Or if you want to be fancy, ab root of n to the b minus a, b plus a. This would be a really good equation if it was equal to 1. It would be extremely good if it was equal to 1. Okay, anyways. 5/3, 5/7 to the 1/7 divided by 5 minus 4/7. This might seem like a hellhole, right? But if you do it, it's actually quite easy. 5/3 to the 5/7 is 5/3 times 5/7 is 5/10, right? And then 5/10 to the 1/7 is just 5/10, okay? Since it's all over 5 to the negative 4 over 7, you can add 10/7 and 4 over 7, you'll get 5/14, which is 5 squared, and then we got the square root of 5 squared, that's just 5. So the answer is literally just 5. Right? See, you can break down a complicated equation and then you'll make it simple. The answer is just 5. Next line. Solve equations with Irrational expression. Now, I'm going to have a phone right here because there's no way I can do these in my head. No, absolutely no way. So, we're looking at the examples right here. X plus 4 to the 3/5, x plus 4 to the 1/3 minus 25 is 100. They're both x plus 4, so you can just add them together. 3/5 plus 1/3 is 14 over 15, right? So 14 over 15, now you do the 15th root of 125 to the 14th power, right? In the calculator, because there's no way you can do it in your head. Just like stop lying. You'll get 90.6, and then subtract 4, you'll get 86.6. Simple. Same for this one. This one's a little different because there's two solutions. You add 314, you get 729. Now the sixth root, when you take the sixth root, is basically taking the square root and then taking the third root. So when you take a square root, there's two solutions to an equation. Therefore, when you take the sixth root, or the fourth root, or the eighth, or the 10th, or any even number root, you will still get two solutions. It's a plus or minus. So the sixth root of 729 is 3. And then you subtract 5, you either get -2 or -8. And those are the two solutions. So we're going to solve these equations by ourselves, okay? X plus 5 6 to the 2/3. So in order to make this 2/3 become 1, gotta multiply that by 3/2. Gotta also multiply this by 3/2, right? In order to multiply it by 3/2, so you remove this thing, 64 to the 3/2. That's the square root of 64 cubed. So what's the square root of 64? Square root of 64 is 8, cubed is 512. So 512, remove all of this, x plus 56 is equal to 512. Right, and we gotta make sure if there's multiple solutions or not. We took a square root. We took a square root, so there should be multiple solutions. So plus or minus, right? If you take a 3 over 2, you're taking a square root. Therefore, there will be multiple solutions. Plus or minus 512, subtract 56, you'll get either positive 456 or negative 578. And those are your two answers. Okay, x minus 36 to the 4/5 plus 8 equals 20. So add 8 to both sides, you'll get x minus 36 plus, so let's remove that, right? So now we have plus 8, and then in order to do this, we gotta take it to the 5/4. And since the bottom's an even number, there will be two solutions. So then we'll take this to the 5/4 as well. So 28 to the 5/4 is, let me get out my phone. 28 to the 5/4 is 64.409. So I'm gonna do 64.41. X minus 36 is equal to 64.41 plus minus. So then you add 36, you either get x equals 100.41 plus minus, or you will get x is equal to, actually, you'll get x is equal to negative 28.41. This is not plus minus. It's not supposed to be plus minus. It's just 100.41 negative 28. Okay, next. This might seem very, very confusing, but it's not. So, x plus square root of 2 to the 1/2 power plus 8 equals 4 minus 3 times 4 plus 3 times square root of 2. So first of all, you subtract 8 just like any normal. You want to get the x. So you subtract 8, you'll get x plus the square root of 2 to the 1/2 power is equal to negative 4 plus 3 times the square root of 2. You square it because it's put to the 1/2 power, so you square it. It's basically putting the square root over the whole thing. Square this as well. You will get, it's going to be a long lesson. Okay, I need to put this down. I need to put my handmade square root. I need to put, oh, I don't want to, I need to put that down. Okay. So negative 4 times plus 3 squared, 2 squared is 16 plus 3 times 3, 3 times 3 squared, 2 times 3 squared, 2 is 9 times, so 3 times 3 square root 2 square root 2, so that's 18. And then negative 4 plus the square root of Negative 4 times 3 square root of 2 2 times is negative 24 square root of 2. So then you will have, and this is plus minus. Actually, no, this is not plus minus because it's a square, not a square root. Actually, it is plus minus because yeah, it is plus minus because no, it's not. And never mind, it's not plus minus because you're squaring something, and when you square it, you can't. When you do the opposite operation, you cannot do the negative version of it. So you can't do plus minus. So x plus one, x plus the square root of 2 to the 1/2. So we still have x plus the square root of 2. Now you subtract square root of 2. You will have 34 minus 25 square root of 2, and that is your answer. Simple. Next, x plus the square root of 3 to the 4th power plus 5 equals 1/4. So you add 5 both sides first, you'll get x plus the square root of 3 to the 4th power equals 16. You take the 4th root of both sides, right? Since you're taking the 4th root, you have to do the plus minus. So x plus the square root of 3 is equal to plus minus 2. Subtract 3. Subtract the square root of 3. You will have negative the square root of 3 plus or minus 2. And that is your answer. Right there. Next. I think this video is going really long. 17 minutes. Simplifying radicals. You have to decide which one is wrong. I think I've already done some of this. But decide which equation is wrong. 5th root of 5 plus 4 times 5th root of 5 equals 5 times 5th root of 5. Is that correct? Yes, it is correct. It's correct. Okay. 2 times 3 root of 16 minus 3 root of 54 is equal to 3, the third root of 2. So 3 root of 2. I don't even know why I said it like 3. Okay. 2 times third root of 16 is, there is 2 times 2 times 2 times 2. There's 3 2's. So you gotta take the 2 out, so 2. Now we have 2 times the third root of 2. No, just 2. Okay, so then we have 4 times the third root of 2. Subtract. 54 is 3 times 3 times 3 times 2. Since you got 3 3's, you can take 3 out. Now we have 3, subtract 3 times the third root of 2. 4 times third root of 2 minus 3 times third root of 2 is the third root of 2. That's correct. Next, 4 to the 1/3, 4 to the 2/5, 4 to 11/15 equals 0. 4 to the 1/3, 4 to the 2/5 is, just add the exponents together. You will get, that's 5, 5/15, 6/15, so 11/15. So you have 4 11/15 divided by 4 11/15, which will get you 4 to the 0. But however, 4 to the 0 is not 0. Not 0. It is 1. So that is not correct. I don't know why I ticked. That's not correct. Square root of 2/3 equals 2 root 3 over 3. This is basically square root of 2 over square root of 3. So we gotta rationalize the denominator. I think that's next slide. So you take square root of 3 on both sides. You will get 3 down there, and then you'll get square root of 6 up here. So the square root of 2 over 3 is not equal to square root of 3 divided by 3. Simplify. 5th root of 5 to the negative 1. What's the 5th root of, what's 5 to the negative 1? First of all, 5 to the negative 1, you go back to this slide, you will see it's 5 whatever to the negative, it's 1 over it. So 5 to the negative 1 is just 1 over 5. And then we have to rationalize the denominator. That's equal to 1 stays there, and then that's square root of fifth root of 5. In order to get the bottom to be rationalized, you have to, you only got one 5 in there. You need 4 more 5s. So we gotta multiply this by the fifth root of 5 times 5 times 5 times 5. 3, 3, 4, 5. Okay, and multiply this also by the fifth root of 5 times 5 times 5 times 5, which is equal to, the top will be fifth root of 625, and then the bottom will just be 5, and that's the answer. That's simplifying. I don't know about you, but I think this is a lot more simplified than this. That's me telling the truth. Square root of 20 divided by fourth root of 5. How do you simplify this? Okay, the fourth root of 5. So let's do the same thing as we do on the top. There's 4 5s required, but we only got one of them. So let's multiply by 5. 5 times 5. Let's multiply. Alright, and then multiply this by 5 times 5 times 5. Make sure it's the fourth root. If you want to change it to the square root, you gotta do other things. That's equal to 5. It's just gonna be 5 at the bottom. Fourth root of 5 times 5 times 5. Now, we can't really combine this unless the square root of 20 is at the same root as well. So square root of 20, in order for it to be the same root, that's the fourth root of 20 squared, because 2 over 4 is 1 over 2. So 20 squared is 400. So let's combine that with that. 400 times 5 times 5 times 5 is fourth root of 40,000, which is a big number, 40,000, right? It's a big number, 40,000. There's 4 zeros, so it's 4 times 10 times 10 times 10 times 10. There's 4 tens, there's 4 zeros, 4 tens in it. So you can take the 10 out, put the 4 like that, times over 5. So the simplified version is 2 times the fourth root of 4, and that's the answer. Or 2 times the root of 2. That's the really nice answer. Multiply the conjugate. So when a radical is on the bottom of the fraction and the root's a square root, you have to divide it. You have to divide it by the conjugate. You have to multiply, not divide, multiply by the conjugate, a negative b. So the square root is the one that has the sign flipped. So for example, in this equation, square root of 4 over 5 is square root of 4 over square root of 5. Technically, you don't need to flip the sign, but for education's sake, let's flip the sign, right? Negative square root of 5, negative square root of 5. So now, square root of 5 multiply negative square root of 5 is negative 5. And square root of 4 multiply negative square root of 5. Well, square root of 4 is 2. Multiply negative square root of 5 is just negative 2 times the square root of 5, and that's the answer. Next, 9 times 3 plus 25. I think I did this a little wrong. 9 times 3 plus 9 over 3 plus 25. What I meant to happen was have it as 3 over square root of 3, right? And then plus 25, so plus 5. I don't know if it's correct or not. But let's do it anyways, okay? So we'll multiply that by negative square root of 3 plus 5. You can still leave the plus 5. It just has to be negative square root of 3, right? And then same thing on the top here, square root of 3 plus 5. On the top you will have, split the order over 15, subtract 3 square root of 3, and at the bottom you'll have 3 square root of 3, so that's minus 3, plus 25, so 22, and then you won't have anything of it. You won't have a rational radical at the bottom because you rationalize the denominator. So 15 minus 3 square root of 3 over 22. Next, square root of 8 minus square root of 18 plus 5 is the denominator we have to deal with. Square root of 8 is just simple. Because it's 2 times 2 times 2, we can take 2 of the 2's out, the last 2 stays in there. So 2 square root of 2 minus 18 is 3 times 3 times 2, take 2 of the 3's out, and then the 2 stays in there. 3 square root of 2 plus 5 equal to negative square root of 2 plus 5. Now we'll have, let's split that order, so 5 minus the square root of 2, 4 minus 4 minus the square root of 3 over 5 minus the square root of 2. We'll multiply that by 5 plus the square root of 2, multiply this by 5 plus the square root of 2. We will have 5 times 4 is 20. 5 times negative square root of 3 is minus 5 square root of 3. I don't even know if it's gonna fit. Minus 5 square root of 3, right? 4 plus 4 times the square root of 2 is 4 square root of 2, and then negative square root of 3 plus square root of 2 is minus square root of 6. All over 5 times 5 is 25, and then minus the square root of 2 plus the square root of 2 is minus 2. So remove that 25 is 23, and that is your messy fraction, but it's the answer. 5. Let's have some practice simplifying. Basically. Okay, so what's 6 divided by 3? First of all, you simplify the numbers and then you simplify each individual exponent. What's 6 divided by 3? It's 2, right? That's easy. So on the top it's x to the first power. This is square root of x, but square root of x is basically x to the first power, and then the square root is a second root. So we're gonna have 2x to the 1, and then this is at the bottom it's 1/2, so 1 minus 1/2, and then 3/4. Y is 3/4. Y is the same as x minus 1/2. You will have 2x to the 1/2, y to the 1/4, which is 2x, 2 square root of x, 4th root of y. Or you can make that simpler, but I'm not going to because that's pretty simple. 9w to the 5th power minus w times w to the 3rd. So we have 9, which can go out of the radical because 9 is 3 squared. So 9 goes out as 3 because 3 times 3. Okay, w to the 5th power can go out twice. It's w times w times w times w times w. That's 2 times 2 w's. W can go out twice. You have 3w times w, and then inside stays a w. But you actually don't have to do that. There's a w cubed in there. Since there's a w cubed in there, we only want w to go out once. So 3w, w cubed. Now they have the same w cubed inside. So since the term inside w cubed is the same, which is 3w minus w is 2w, square root w cubed, and that's our answer. And then we can obviously take the w cubed out. Now we'll have 2w squared, square root of w, and that's the simplified answer. Next, I don't know how long the video's been. I think 40 minutes, nearly. So we'll find the perimeter in the area of the triangle. Okay. So the problem in the book was too easy, so we'll do this instead. Okay. So square root of 2. We'll use Pythagorean theorem because these are square triangles. Square root, right? And then these are square root as well. So square root of 1 times square root of 7. So 1 squared plus 7 squared is equal to let's do a, that's b, and that's c, right? So 1 squared plus 7 squared is equal to a squared. So we have 50 equal a squared, and a is equal to positive only 5 square root of 2. Right? We found a, right? B time b. is square root 2 squared plus square root 24 over 2 squared is equal to b squared. Square root 2 is 2. Square root 24 over 2 is 24 over 4, which is 6, equals b squared. 2 plus 6, 8. 8 equals b squared. b is equal to square root of 8, which is 2 square root 2. How about c? c is equal to 2 square root 2 squared plus 5 square root 2 squared. c squared, that is. And what's 2 square root of 2 squared? That's 8. 5 square root of 2 squared, 50. So 58. So you take the square root of 58. That's just square root of 58. There's no way you can change that. Right, so you add a, b, and c together. 2 square root 2 plus 5 square root 2 plus square root 58. You will get 7 square root 2 plus square root 58. And that is your perimeter. 7 square root 2 plus square root 58. Now we have our a and we have our b. So let's erase everything but our a and our b. We can even erase our c. So a and our b. Now they both meet at a right angle. So that's easier for us to be able to find the area. So they both meet at a right angle. So we use the triangle area formula. 5 square root 2 times 2 square root 2. Divide that by 2. 5 square root 2 times 2 square root 2. That's 20. Plus 5 times 2 is 10, and square root 2 times square root 2 is 2. 20 divided by 2 is 10, and 10 is the answer for area. Okay, final question. This is it. After this, we're done. I'm not going to do any more. Determine whether the expressions x. Okay, sorry I did not show you the measurements. It was square root 2 and square root 24 over 2. Determine whether the expressions of x squared to the 1/6 and x to the 1/6 squared are equivalent for all values of x. I'll give you a minute if you want to pause. You can think about this, but I'm going to give the answer right now. So the answer is no. The answer is no, they are not equivalent for all values of x. Let's say x is negative x is negative 64. X is negative 64. We'll put it in this, right? So negative 64 squared to the 1/6. What's negative 64 squared? 4096. And then 4096 to the 1/6 is the 6th root of 4096, which is 4. However, negative 64 to the 1/6 is undefined. You cannot do it. Negative 64 to the 1/6 is not a thing. It's not a valid solution. It would be 2i. Because it will be I to the square root of 64, which is 8i, and then 8i to the 1/6 is just a mess. 8i to the 1/6 is just this is 64i. Never mind. This is 64i squared, right? 64i squared. 64i squared to the 1/6 is 2i to the 1/3, which is 2 to the cube root of I, which doesn't make sense. And then you square that. You'll get 4 2/3 root of I, which is 4 3/2 root of I. What am I doing? You'll get 4i to the 2/3, not 4 2/3 root of I. 4i to the 2/3, which is not equal to 4. Therefore, these two expressions are not equal to each other. That's gonna be it for today's episode. I said that's gonna be it. I shouldn't say that. I should say that is it for today's episode, because I'm pretty sure you guys are sick and tired of 35 minutes of math. Um, next episode is going to be, I think, more rational equations. It won't be this long, I promise. Um, but that's going to be it for today's episode. So